Hello, and welcome back to Learning with Lee. In today's episode, we are going to continue to look at C input and output. Particularly, we are going to emphasize file input and output by delving a bit further into some of the more complicated cases of things you can do for file I/O. We're just going to start off with some very basic stuff, which is reading in a file name, opening up that file, stuff that we've already covered in the preceding episodes. We end up doing a little bit of extra stuff in terms of using sprintf so that we can read in a file name, generate a string with that file name included in that string, and then opening it up. Then we are going to read in and create a polyhedron. And for those who are wondering what polyhedron is, who it might have been a while since you've taken things like geometry or the like in maybe junior high, middle school, or high school, what a polyhedron is it is something similar to a cube. Or think about it like a Minecraft block. One cube in Minecraft, one block in that, is a polyhedron. And on it there are multiple sides, and those sides are known as faces or facets. We're going to be getting into a lot of modeling stuff in the future and geometry in 3D. But for now we have some very, very basic implementations of it in that basically it has a series of points that represent the vertices, and that has a series of facets, and each one of those is a face on it. And for these facets, all that they have are indices of which points, which vectors, which vertices happen to be used to represent that face. And then for this, for vector 3D, which is what we're using to represent our points, is it just happens to be, you'll wonder why it's 3D and we have this W down here, but that's going to be a discussion a long time in the future once we really get into computer graphics and how they work. However, for now, really all you have to know is that it has X, Y, and Z within it so that we can deal with those. So, what we're going to do is we're going to read in something similar to a Minecraft cube, and we're going to create all of these objects accordingly. And you might be going, okay, that's a bit more complicated than what we were looking at yesterday. For now, we're going to do this a couple different ways. So we're opening up our file, and our file right now is just this. It's not a particularly complicated way of having it stored. It's a fairly simple way of having it stored, but it's fairly reasonable. And I'm using some very basic examples for our points, just saying that it's a cube with one for each length on a side. Then what we're looking at is we're going to read it in, and we're just going to output that file. And there's a few key things I wanted to touch on in doing this, because this one here is a few of the more basic and beginning things. So the first thing that we're going to look at is, we've already touched on FEOF just to check that we aren't at the end of the file. So that's the first thing. We make sure that we're still within the file, we haven't reached the end of it. Then, fscanf. We've already went over printf and all the different things you can do with these percentages, and you can do basically the same set of things for the most part when reading something in. There's a few limitations, but there is an important thing to note about the way that fscanf works. And you can see that by the combination of fscanf and fprintf. And you might be thinking, okay, well this is just going to take until some certain point. It might take a full line, it might take until we filled up our buffer, it might take some other amount. But the answer is that it takes until it hits white space. And white space is anything along the lines of a new line character, a tab, a space, just normal little spaces like that, a vertical tab if your operating system supports those or if those exist within your text document, or anything else like that. So if I give it a %s, meaning I want to read in a string, and I want to read it into line, and the reason why it's line and not the reference to line or the address of line is that line is effectively a character pointer, if you'll remember, since we're dealing with an array here. So we only need to pass this in, and then it'll effectively redirect it to the first location within these 250 bytes of memory. So then we scan it in, but down here you can see, okay, we end up getting polyhedron, we end up getting points, but then down here it gets really interesting. And that's because each one of these little spaces between these zeros all of a sudden treats one of these as what's known as a token. Just basically one series of characters that could easily be converted into an integer, into a double, into whatever you want to really use it for. But it's one item with basically spaces on either side and no white space within it. And what its exact type is doesn't much matter, so long as you know that, because you can just basically transform it into whatever the appropriate type is at that point. You don't have to worry about trimming away white space or dealing with end-of-line characters or anything else like that. So this is effectively tokenizing or converting what was previously lines into just these individual tokens, and then it's outputting them one at a time on a line thanks to fprintf here. Then there is another thing, and we already discussed to a certain extent getChar and putChar. However, there is an important thing to understand, and this is sort of the difference between if I did printf and fprintf, and that's that putChar and getChar automatically assume that you're dealing with standard in and standard out. However, fprintf can be given pretty much any file pointer, and the same thing is true for putc and getc. So even though I'm using standard out, which I could just use then putChar and get rid of all this, I want to introduce the concept of putc because of the fact that it's basically the same as this, but you have the second variable, second argument here, that you can supply in order to give yourself a bit more variability and a bit more control over the exact operations of your operating system and of what you're outputting. Here's another important thing to understand about this and how this ends up working with files in particular, and that is that as you go through it, whether you're using fscanf, whether you're using getc, getChar, or really any other function to advance through a file, well, any other standard library function to advance through a file. You might have your own custom ones or use a third-party ones that don't behave in this way, but for those that exist within C by default, they will all move your pointer, this little file pointer, forward in the file. And you remember last time how we ended up outputting how it has different things like a position in it. It ends up having some flags is a different option. Eventually you're going to reach near the end of your file, and what you might want to do then is you might want to seek, or in some cases, because of the way that your file might be set up, you might either need to go earlier or later in a file and either ignore certain data or go back over certain data. And for this, what you end up using is you use fseek or file seek. So it takes in a file similar to really any of these, whether it's standard out or F for our custom file. It takes in a long, hence the L that we have after the 0, and that tells you how much you want to adjust your current position, or more accurately, how much you want to adjust your position relative to some origin. And this third thing is the origin, but it's important to note that this is not a location within the file. You can't just go, okay, I want a certain number of bits within or bytes within the file, and then start from there and go relative to there for my offset. What you have to do is you have to go either at your starting location, at your current location, or at the end. So in this case here, we're going back to the start. We want to be offset 0 bits, so we want to be at the start. In case I put in 10, it would shift me 10 bytes off of the starting position forward. In case I put in a negative number from there, we would have a bit of a problem. In case I ended up having it from the end, I would want this to be negative so as I'm going earlier into my file. Or for my current, I would want negative if I wanted to go earlier, and positive if I wanted to go later into the file. But that's fseek. And I've already mentioned fflush in an earlier one, so just as a brief reminder, that ends up causing whatever's currently in the standard out buffer to be forced to the screen, or to be forced to whatever file that corresponds to. In this case here, it corresponds to the screen, but for other things such as, in case I did that with F and I was outputting to F, I could end up doing that to force it to the hard drive, effectively. So that's the first thing, and that generates all of these little ones and zeros and then points, facets, down through here and then down to here. So once we're done with that, what we're going to do now is we're going to load in this polyhedron. So as it ends up existing in our code as this particular class, as well as the associated classes that uses. So for this, what we need to do with it is we're going to go down to this method here. And there's quite a few different ways in which you can approach this problem. However, for the most part, we're going to end up using fgetS, which I know that we went over some in the earlier episodes. And the major reason for that is that it stops as soon as we hit a new line character, or our limit, in this case here, 250 characters. So what we end up having to do is we're going to get that in, and the reason why I end up choosing to operate on a line is that typically it's a bit cleaner to do your operations line by line when you don't know how things are formatted. the points and the facets could be reversed, so I don't know the order of them. I don't know which of these is coming first and which one's second, so it's better for me to basically check one line in order to then modify my behavior going forward. So this outer loop is really just looking for, and as you can see in here how we have this if statement here and this else if down here, it's looking for these higher level definitions of blocks. It's looking for where we end up going, okay, we're either start polyhedron, start points, start facets. Or really, we can even frankly ignore where it starts polyhedron, because that doesn't matter to us when we're scanning through this. All that we care about is, okay, we're done with that, but if, for example, I wanted this to have multiple polyhedrons, so that I could then go something like that, I would actually want this to then care about when we hit a polyhedron, so that it can then read in and scan that section of it. What this is really caring about is these different tags here, and then it's leaving it up to other functions in order to handle what's within those particular tags. One other thing about this, before I get too far ahead of myself, and that's that I'm using stir and comp. So that's because I want to keep this all C style for how this is done. So one of the things that we want to do is we want to compare the strings, as well as also we just want to compare the first however many characters is in this string to the right here, because the line should match this number in case we are actually at where we want it to end up being correctly. And you can see up here how I don't have this not equals 0, and that's because of the way that Booleans work in C is that effectively, if it's non-zero, it's true. I know we've gone over that a few times, but it always helps to have a bit of a reminder. So either one of these or these is a perfectly fine way of doing it. Then, within here, we're just, once again, doing stir and comp in order to compare to see if we're in our points section or in our facets section. And then within those, we have a sub-while loop in order to basically deal with the unique details of each one of these. What we're doing then within here is we're going to go through and we're going to create a facet and we're going to create vectors. And then, provided that we actually succeed in doing that, we're going to add it to our polyhedron's points and to our polyhedron's facets. Down here you can see how exactly we're doing this. And you can see that scanf looks fairly similar to what we were showing earlier on with printf, fprintf, and so on and so forth. And the major thing about it is that we have these little %lf space %lf, and I could have as much space as I want to in here. The only thing that matters is if I say did a %hyphen in here, it would actually fail for the way that poly currently happens to be done, because there aren't hyphens between them. Anytime in which you have a non-white space character in something like scanf that isn't part of something that you're scanning in, it expects for that literal value to be in the string there. So as it can go, okay, you are using whatever thing you're using either to delimit something, or you're trying to read around something. So in case, for example, this were days or time, we could do it sort of like that, where we have our little slashes going forward to signify some number of like days, months, years, years, months, days, years, depending on where you live in the world. But that would end up being valid and viable. You could also do something like comma delimit this if you wanted to. And when I use the word delimit, that just means to have something that separates two tokens. So I have one token here, and then I have something here, which is a delimiting character. And then it separates it from the next token, and so on and so forth. And for most of this, it just assumes that you're using white space as your delimiter. Then, scanf is a bit interesting in what actually returns. It normally returns the number of these you successfully ended up matching. So typically you want to make certain that you ended up matching all of your items within there. Occasionally, if you have something that has optional parameters and the like, you might actually just say, okay, well, let's say that we only care about if it's greater than 2. We don't care if z ended up being matched, and in case it wasn't, we just have it, say, equal to 0 up here. But for our particular case, it does actually matter that we have exactly 3 that get matched, because otherwise we're missing a point in our vertex, which obviously makes it nearly impossible for us to draw it without just inferring that it needs to be 0 or some other value. So at that point, it's pure guesswork. However, then, scanf can also have a bit of stuff in terms of, in case you reach the end of a string, it treats it as the end of a file. So it can actually set stuff like FEOF, which is a bit weird, but And it can also return end of file in case you aren't expecting this. So in case you end up just going, okay, while I do scanf, if I hit the end of the file, it doesn't end up returning 0 saying that I couldn't create any of these. It returns EOF. And EOF, at least on my particular system with my particular compiler, ends up being -1. So that's a problem. So that is something to be aware of, that you do in general want to compare it with what you're looking for. And in case you happen to be looking to compare it to something like either 0 or end of file, because either one of those are going to be your typical fail states, you're going to then want to end up having it go basically store this in some variable for whatever integer you get out, and then use that integer for comparison so that you can compare it multiple times. Because otherwise I would have to do basically this scanf twice, once to check that isn't the end of file and once to check that isn't 0. So it just is better to either go greater than 0 or to have it equal to a specific number that you're looking for. But that's really all that you need to know about scanf, and you can see that we just then... Oh, and I did mention this briefly, and I did sort of emphasize its importance in the last episode on this, but you need to, when you're passing in something to scanf or scanf, you need to pass in an address, so it can actually modify your variable itself. Because otherwise it passes in a copy of that variable, and as a result, it doesn't have the ability to modify x if I just pass in x directly. It only has the ability to modify a copy of that. And it also, because of the fact that it's expecting a pointer, will then try to modify potentially memory you don't have access to, which could cause your program to crash. So that's how parse vector works. Parse facet is very similar, but it's a bit different, and the main reason it's different is that we don't know the number of vertices that a facet is going to have, because it could be a square, it could be a pentagon, it could be a hexagon, it could be some weird shape with 15 vertices that ends up being self-intersecting and has a whole bunch of other oddities to it. So the fact of the matter is that we need to figure out how many vertices are there. But we can do this without actually having to do any counting, without having to actually determine how many different spaces there are in there. And the trick that we're end up going to use in this is basically we're going to use scanf in order to tokenize it, and then we're going to use searcher, which once again is searching a string for a character to advance to the location of the next space. And once again, we've gone over searcher and a bunch of the different string methods that exist in the past, and in case it ends up failing, it returns a null pointer. So long as we're able to successfully find where this is and it's not null, we can then go one beyond, and that's why we have to do this plus plus, is that right now, having this little space here says that we end up going to that location. We don't go to the character beyond it. So if we're looking at something where it's lf space this, we end up getting a pointer back to this space right here. When really, we want to be dealing with this object right here the next time we hit scanf. Because otherwise we can run into some issues, and I can't do something like space this, because otherwise it fails on our initial case. It fails for our first %lf, otherwise I'd have to deliberately insert an extra space to the beginning. Which could work, and it might actually make your code a bit more compact and clean, but that's really a personal preference choice at that point. So all we're doing is we're basically tokenizing it, going over each token, and once again using this to go over the line, and advancing beyond that token once we've actually grabbed that token and added it to the set of points for that facet. And that's really all that we have to do for reading in this. And with that, we've really covered the vast majority of what you need to understand about C file I/O. Beyond here, there's really only a couple things I want to take a look at. And that's low-level file I/O. So far what we've dealt with is we've dealt with a lot of things that exist to make it easier for you to do file I/O, but we haven't dealt with the most efficient versions of file I/O. So I'm going to get into those, and then binary files over the next 1 or 2 episodes to wrap up our look at C file I/O. And once we're done with that, we'll move on to C++ with streams, so as we can deal with I streams, O streams, but that happens to be what we're going to be dealing with in a few episodes. So thank you very much for watching. Have a wonderful day.